Let's look at what is the prime factorization. Okay, so basically, so a prime number, which is a factor of a composite number, is called a prime factor of the composite number. Okay, so a prime number is a factor of a composite number. So then we call that, what do we call that? A prime factor. Okay, so we call it as a prime factor. Okay, so and then we already discussed, right? So what is the prime factor? So let's give an example. So for example, we have number 13. So what's the number 13 is a composite number. So we know that. So basically, they have prime factors like 2 times 3 times 5. So okay, we call this one. Okay, so then we call that, so 13 is the composite number. Alright? So 2, 3, 5 is the 2, 3, 5 is the prime factor of the composite number 13. Okay, so in this case, okay, now brings to the very important concept. Very important concept. Okay, so we bring a very important concept. So the way to express a composite number as the product of the prime factors only is called prime factorization. Okay, so it's the way to express a composite number as a product of prime factor only. So we call that, what do we call that? We call the process is prime factor only is, we call this whole process is prime factorization. Okay, so we call this, okay, the way to express the composite number as the product of the prime factor only. Okay, prime factor only, right? So prime factor only. So in this case, okay, 13, let's express 2, 3, 5. 2, 3, 5 is a prime number. So it's only a prime factor. Okay, so what is opposite? Opposite. So for example, okay, let's say opposite. Let's look at the opposite. So let's look at the opposite. So for instance, if we specify as a 6 times 5, okay, no, this is not a prime factorization. Okay, so this is very clear, right? Even we specify as the 13 equals to the 2 times what? 15, right? So, okay, again, this is no, right? This is not a prime factorization. So every factor must become a prime number. So if this is the case, then okay, so we will see that okay, the process is the prime factorization. Okay, so this is very clear because this here is because of this, right? And here is because of this, right? Okay, you can still break them down to the 3 and 5, right? You still can bring them down to the 2 and 3, right? So this is very clear, right? Okay, let's give an example. Let's give an example. Let's give an example. Okay, let's so we have an example to find the prime factorization of a 1020. Okay, so how we do that? Okay, so basically we can use the factor tree. We call that factor tree. So 1, 2. How we write that? Okay, so factor tree. We can break them into 2. Okay, first we try the 2. How much we get? 5, right? Here is how much, right? Here is 10. Here is the 10, right? Okay. So this one continue the factor tree. So what we get? So we can use the probably 2 again, okay? Or we can use the 10 as fast 10, 51, right? So then this one we can still break down as 2, 5. And how about this one? This one we can break down to what? We can break down to 3, 17, right? Okay, so in this case, so we can write this equation as 1020 as what? That's 2 times 2 times what? 3 times 5 times 17, right? Can we write in this way? This equation, right? And don't forget we have another way. We also have another way to express this. Another way to express this. This is the method 1, right? So we have another way to express this. Okay, so we can use the we can also find the prime factorizations of the number by the successive short derivation of the number by the prime number until the quotients is reduced to 1. So what's the meaning? The meaning is we can use the successive short derivation. So for example this, so 1 to 20, right? Okay, so 1 to 20 we can use the here with how much? 2, right? So we get how much? We got 5, then we got 10, right? So what the next one? Next one, can we use 2 again? 2. So how much we get here is 2, right? Here becomes 11, so it's the 5. So here's the 5. So because it's 10, so it becomes 10, another 10, so 5. Then, okay, how about here? Around here, so can I use the 3? Let's try 3. So 3 is about 8, right? So 15, 5. Okay, it's good. Okay, let's continue. Let's hop on here. Come to here, we have to use a 5. 5 is 1, so 7, right? So 17, right? So how to divide by 17? Just use the 17 itself. Then we become the quotient become 1. Okay, so we call this method successive short derivation. So we get a 1. So and we also can get the same results here, right? We can get the same results here. We'll get the same result. Okay, so basically we have 2 methods. So this is the first one. Use the factor tree. Or the second one. Second one, use the successive short derivations. Okay, so basically we'll use the 2 different methods. So the first one, factor 3. Second one is this. Okay, two ways. Okay, let's give another example. So to find out different number, use the both way. Okay, factor 3, and then the successive short divisions. Okay, let's try one more example. Okay, there's one more example here. So let's find out the 5, 8, 5. Okay, 5, 8, 5. Okay, the first way. We use the factor 3, right? So 5, 8, 5. So how to find this number? So 5, 8, 5. So what do we have? So basically we have a 5. Okay. You've got a 5, right? We just try 5 first. So how much we get? It's a 1, it's a 1 and 7. Alright, am I right? So let's continue. This one, can we try 9? 9, how much we get? We have 1, then we have 3, right? Is that alright? So what's the number we get? Okay, so straight away we have 5, 8, 5 equals to 5 times 9 times 13, right? Okay, so this is the result we got, right? Okay, let's try that another one. So can we use a different method? Use the second method, successive short division. Okay, let's try the second one. Okay, second method. Okay. 2. Successive short division, right? Okay, so we can use this one 5, 8, 5. Okay, let's try 5. How much 1? This is how much 1, right? And 35 is 7, right? Next one. So can we try 9? It's the same thing, right? So first one 1, then 2 and 3. If of course we can use this one, then we get 1. So the quotient is always asked to the 1. So this is called a successive short division. So we can get the same value 5, 8, 5 equals to the 5 times 9 times 13, right? Okay, we get the same result. For this example, the 2, right? This is the second example. Okay, so okay, here we go. We got one more. Okay, here we go. We got one more. Sorry, we got 2 more. Okay, let's find another one. Okay, let's look at this example. Okay, so basically we have a 3, 1, 3, 5. Okay, so how we separate this? Can we divide by the 2? No. Can we divide by 3? Yes, seems like we can divide by 3, right? So how we get? We get 1, we get 0, 4, 12, 15, 5, right? How about this one? Continue. So can we divide by 5? Yes, 5, 2 here. Then we get 0, right? Then we got how much? 9, right? Okay, let's continue. How about this one? What we get? 11. So 11 we have a 1, then we divide. Okay, so 19, right? Okay, so we get answer here. Therefore, so 3, 1, 3, 5 equals to 3 times 5 times 11 times 19, right? Okay. Now we find the answer. Okay, can we use another method, another solution? Successive short divisions. Okay, let's look at this one. Okay, let's look at this one. So we have a 3, 1, 3, 5. Okay, let's first try 3, right? 1, here's a 0, here's a 4, and 5, right? Okay, let's look at the next one. Next one, 5, right? Here's 2, here's 0, here's 9. Okay, let's look at this one. 1. We have a 1 here, right? Then we have a 9. Okay, so then we have 19. Then result is a 1. Okay, so what is the answer? The answer is 3135 equals to 3 times 5 times 11 times 19, right? Okay, we got the same answer, right? Okay, quite straightforward, right? Okay, we try one more example. So let's try the last one. Okay, same way. We always have two ways to resolve this question. Okay, let's try one more. Okay, let's try one more. Okay, 2730. Okay, 2730, the factor trace. Okay, let's try factor trace. 2730. Okay, so can we divide by, for example, we try 10. Okay, 10 to 73, right? Okay, so apparently here we have 5, 2, 2 and 5. How about here? Can we 3? 3 is 9, right? It's 1, right? Okay, so what do we get? Can we get this one? Continue. Let's try 7. 7 we get, okay. 7 we got 1 and we got 3, right? Is that correct? Oh yeah, it's correct, right? So in this case we got answer now. So 2730 equals to the 2 times 3 times 5 times 7 times 13, right? Is the answer, right? 1, 2, 3, 4, 5. Okay, good. Okay, let's use another way. Okay, another way. So again here, 2730. Okay, so same thing. Okay, let's look at 2 first. 1. How much we get here? 3, right? 1, 13, 6, right? So it's 5, right? Is that correct? Yes, okay, that's good. So we'll have a 10. Yes, okay, let's try continue. Okay, how about 3? 3 we got 6. Sorry, we got 4, right? Here's a 4, right? We got 4 here. Then we have a 16 and 5. Then another is 5, right? Is that correct? Okay, let's continue. So how about 5? 5, yes, of course. 9, this is the 1, right? Continue. Okay, how much we get here? We have used the same thing, 7. This is 1, 3, right? Then again use the thing, then become 1. Okay, good. So therefore, 2730 equals to 2 times 3 times 5 times 7 times 13, right? Okay, we get an answer. Okay, that's it. Okay, let's okay, after these 4 examples, probably we can just do a simple summary and some remarks. Okay, so let's give some remarks. Okay, let's give a remark here. Okay, so let's do. Okay, first one. A number is divisible by 3 if the sum of the digits is divisible by 3. Okay, so basically, if you have a number is divisible by 3. A number is divisible by 3 if, okay, if the sum of this its digit its digit is divisible by the 3. So what's the meaning? Okay, let's look at this one. Okay, 2730. Okay, let's add up all the digits. So let's use this one. So how many we get? We got 2 plus 7 plus 3 plus 0, right? So how much we get? 9. Okay, 12. Okay, the 12 divide sum of the digits divisible by 3. Is that divisible by 3? Yes, we got 4, right? Okay, so this number, the number is divisible by 3. Okay, so in this case, it definitely can be divisible by 3. So what's that? So here is 9, right? So about here, 1. Okay, good. This is correct, right? Okay, remember this remark 1. Okay, let's look at the second one. Look at the second one. So a number is divisible by 5 if its last digit is 0 or 5. A number is divisible by 5 if, what's the if? The if its last digit is 0 or 5. Okay, this is very easy to understand, right? So for example, here is the same example. So 2730, right? So what's the last digit? The last digit is 0, right? It definitely can be divided by 5. Okay? So here's how much? Here's 5, right? 25, right? Here, how much can we get? 2, 3. So this is 4, right? 20, right? 30. And we got 6, right? Okay, 0. Okay, good. Okay, this is very simple, right? So we can understand that one. So let's remember these two remarks. Okay, this is two very important remarks. Okay, this is very helpful when we do the prime factorization. Okay, so basically the first one, if a number is divisible by 3, so okay, the number is divided by 3. Okay, it's already defined. Okay, you'll be able to divisible by 3 if the sum of this digit is divisible by 3. Okay, just somebody try 1, 2 plus 7 plus 3 plus 0. Okay, so it's 12. 12 is divisible by 3, and then this number is definitely also divisible by 3. Okay, a number, the second remark is a number is divisible by 5 if its last digit is 0 or 5. Okay, this is also easy to understand, right? Because if you have a 0, your last number is 5, then definitely you can able to divide by 5. Okay, so 5, the last digit. Okay, the last digit is 0 or 5. Okay, that's good. Try. Please remember these two remarks. Okay, so this is the prime factorizations. Okay, thank you.